Hello and welcome. This is a lesson on Earth's atmosphere. Get ready to learn. Did you know? The Greek words atmos, vapor, and spheria, meaning sphere, make up the word atmosphere. So it's a sphere of vapor. That's where the word comes from. We exist due to a delicate balance of gases that make up the atmosphere. Now, if the Earth were the size of a basketball, the atmosphere would be as thick as a single piece of paper. So it may seem like there's a lot, but there really isn't. But it supports all life. Why is it important to know about the atmosphere? If the balance of gases is slightly altered, major changes can happen. Knowing about the atmosphere helps us to understand our planet and also how to preserve it. Without the atmosphere, the Earth would be like the moon. No life, no water, generally a rough place to live. Greenhouse effect. Greenhouse effect is not a bad thing. It keeps temperatures constant. In other words, sunlight enters our atmosphere. Some of it goes right to the ground, and you can go outside and feel it. Some of it is bounced up and back into the atmosphere. So the atmosphere captures some of the radiation and balances out the temperatures. So the greenhouse effect is not a bad thing. It allows us to be alive. Now, the other thing is that air has mass and takes up space. I know you can't see it, but it's held on Earth by gravity, just like everything else is held on Earth. So it has mass. You can feel it. If you blow on your hand, that air blows against your hand. You can feel it. And it also takes up space. You can blow up a balloon. See that. So the greenhouse effect keeps temperatures constant, and air is held on Earth by gravity. Now there are different layers of the atmosphere, and these are pretty much, you can tell one layer from the other based on a couple different things. So out here in space is the exosphere. Exo meaning exit, to leave. So to leave the atmosphere, it's about 425 miles up into space. Exo means outside. Now the next layer is the thermosphere. It's 50 to 425 miles. Thermo meaning temperature. It's hot. There's not a lot of gas there, but what is there is very hot. And this is where the space shuttle used to fly. This is where the space station is now. Next is the mesosphere. This is getting a little, as you can see, the exosphere goes on forever, but the thermosphere is a pretty wide band. Then they get smaller as you go towards the Earth because the amount of material goes up. More and more gas is attracted by gravity. And because there is more material here, meteors burn up here. Well, they fluoresce. They make a bright light as they rub up against the air. The stratosphere here is above the first layer, and it is where commercial airlines fly. They fly above the weather, 7 miles above the Earth. And the troposphere, it's from ground level up to the stratosphere. So it's the most dense part of the atmosphere. We live here. If you look, here is where all the weather is, all the clouds and the snow and the mountains, and we're way down here on the bottom. So, the Earth has an atmosphere, and the atmosphere is broken into different layers based on what happens in the layer, and we'll talk more about that later. Now, at air pressure at sea level, if you're on the beach, it's usually somewhere around 14.7 pounds per square inch. So if you can do this and make a 1 inch square, there is a column of air 1 inch all the way up to space that is pressing down on everything. And not just down, but left, right. We're in an ocean of air. And that weighs 14.7 pounds per square inch, PSI. So at sea level, it's 14.7. But in space, it's 0. There is no air pressure here. That's why we need a space suit. Otherwise, it would be difficult. Now, we need an atmosphere to breathe. No air, no life. Sound is transmitted through air. If you don't have any air, you can't transmit sounds. Two people standing next to each other, well, aside from being dead because there's no life, they couldn't hear each other. Air conducts sounds. No air, no sound. The density air is 14.7 or 15 pounds per square inch. Now, because of that, if we put air inside these bags that we heat up, hot air is less dense. There are less molecules than colder air. So if we heat the air in these bags, it's going to go up, because the air outside is going to be pushing down. This pushes up because what's in the bag is less dense. There is less air inside than outside, so it wants to balance. It's called a hot air balloon. Gases in our atmosphere that allow us to breathe. There are things called pollutants that we put into the air that may hurt us. There are 4 major types of pollution that we really need to be concerned about. One is photochemical smog, sunlight reacting with things coming out of not only factory exhaust, but automobile and truck exhaust. Photochemical smog. Photo meaning light, chemical meaning chemicals. and they create this thing called smog. It's a play on the word fog. Acid rain. Out of the smokestacks sometimes comes a very mild acid that combines with water vapor and makes something called acid rain when it precipitates or when it rains. So we have photochemical smog, acid rain, increased greenhouse gases, carbon dioxide, methane, all break down and increase the greenhouse gases, heating up the atmosphere. And then ozone reduction. There's a protective layer of ozone on our atmosphere that stops particles coming from the sun. And there are gases that will break down this ozone, cause us issues. So we have 4 major types of air pollution. Now, we had a similar chart before, but this one has temperature on it. I want to talk to you about why there are breaks in different levels of the atmosphere. Here we are in the troposphere. Let's start there. As you go up the mountain, it gets colder. We know this. So the temperature goes down. The air pressure changes as we go from sea level, 15 or 14.7 pounds per square inch, up here beyond the thermosphere into the exosphere. This exosphere would be above the thermosphere. We go from 14.7 to 0. So the air pressure changes. It's pretty linear. It goes in a straight line. The atmosphere has several different layers, and the layers protect us from radiation. Some layers, they're separated by the direction of the temperature shift. That's the main thing here. As you go up, you go from warmer to colder. As you go up a mountain, it gets colder. When you leave the troposphere and go into the stratosphere, though, the temperature rises. It doesn't seem right, but it does, because there is less air to heat up. Remember, the air pressure is going down. Most of the air is down here in the troposphere. So as you leave the high density air, the sun transfers its energy to those particles that are left until there are so few left that it starts now going, the temperature really goes down. And then you break through into the thermosphere, where it gets very, very hot. Again, there is very small amount of air particles, air atoms, air molecules. So there's not a lot of them, but what there is very excited by sunlight. So the thermosphere, the stratosphere, mesosphere, and thermosphere, and out here in the exosphere, it's all separated because of the direction of the temperature change with elevation. The balance of gases is slightly altered. Major changes can happen. Knowing about the atmosphere, helps us understand our planet and how to preserve it. Without the atmosphere, the Earth would be like the moon with no life, no water. Generally, a rough place to live. There's your lesson on Earth's atmosphere.